Alright, silly people, here's the situation. Griffiths is going to have us calculate the cosine of an angle theta um, via taking the square root of a bunch of inner products, and then we're going to find what the angle is. So, okay. Uh, we have the two vectors here, alpha and beta, um, that Griffiths gave us for the problem. So let's just do one inner product at a time. Starting with the inner product of alpha with beta, which remember is just the dot product of the complex conjugate of alpha with beta. So this is going to be j hat minus I k hat dot 4 minus I hat plus 2 minus 2 I k hat. That should be enough parentheses. Um, so going component by component, we have 1 minus I times 4 minus I, no j component, and then minus I times 2 minus 2I, right? So I'm just going to stick the minus sign here. Um, just expanding the multiplications, we have 4 minus 4I, whoops, minus another I, uh, plus I squared, and this is going to be minus 2I plus 2I squared. We'll collect the terms which depend on the I. There's the 4 and the 1 and the minus 2, so that makes minus 7I. And then we've got the 4 from before. We're going to turn plus I squared into minus 1. We're going to turn plus 2I squared into minus 2. So that makes 4 minus 3, which is 1. So it's just 1 minus 7I. The next inner product that we would do is beta with alpha, but we know that that's just going to be the complex conjugate of the one that we just did of alpha with beta. So complex conjugate of that. So then it's just 1 plus 7I. So we didn't even have to work for that one. The inner product of alpha with itself will be pretty much what we just did on the left-hand side. So this is going to be the complex conjugate of alpha. So this is an I hat plus j hat minus I k hat. And then we have just what is alpha. So 1 plus I hat plus j hat plus I k hat. Right. So again, going component by component, we have 1 minus I times 1 plus I plus 1 minus I squared. And so expanding that multiplication, it's 1 minus I plus I minus I squared. We still have this plus 1, and then minus I squared will turn into plus 1. So this I cancels out this I, minus I squared, again, turns into plus 1. So we just have 4. That's pretty neat. For the purposes of the problem, though, I'm going to represent it as 2 squared. You're going to see why in a minute. And so beta with beta, though, is going to be 4 minus I hat, but it's 4 plus I because it's the complex conjugate, plus 2 plus I, 2, yeah, 2 plus 2I. That's dotted with 4 minus I hat plus 2 minus 2 I k hat. And so we've got 4 plus I times 4 minus I plus 2 plus 2I times 2 minus 2I. So expanding these, we've got 16 plus 4i minus 4i minus I squared plus 4 uh, plus 4i minus 4i minus 4i squared. Okay, so all of these terms with I cancel out. We'll expand all of the minus I squareds into plus 1s. So you have plus 1 here. We've got the 4 from before. We've got another 4. So it's 16 plus 9, which is 25. And then for the same reason that I'll explain in a second, I'm going to represent it as 5 squared. But that means we can start putting together the cosine of theta now, just using the definition that Griffiths gave us, A28. It's the inner product of alpha with beta, which is 1 minus 7i times the inner product of beta with alpha, which was 1 plus 7i. And then it's divided by the inner product of alpha with alpha, which we found was 2 squared. And then the inner product of beta with itself, which we found was 5 squared. Cool. On the top side of this fraction, I'm going to expand the multiplication, but then I'm also just going to do the square root of the denominator. So this is going to be no need for parentheses now. 1 minus 7i plus 7i minus 49i squared in the square root. So on the bottom we have 2 times 5, carrying that square root out. The i's will cancel out. We know minus I squared is 1, so it's 1 plus 49 on the top, and then we have a 10 down here. So 1 plus 49 obviously makes 50. So you've got root 50 over 10. But we know that root 50 is just 2 times 25, which you can write as 5 squared. And that's over 10. So we can factor the 5 out of the radical, so we just have 5 square root 2 over 10. And then reduce the fraction and get root 2 over 2. So that's cosine theta, and then we know from probably pre-calculus, you've done this before, inverse cosine of root 2 over 2 is just 45 degrees or pi over 4 radians. And that's going to be your angle. All right.